afternoon. Welcome to Specialist Maths Students webinar presented by Texas Instruments Australia. In today's webinar, we'll look at differential equations. The following concepts and skills are on the course of Specialist Mathematics, as you probably had everything in Unit 3, stays the same. So in differential equations, we are verifying solutions to differential equations, and we are solving differential equations in various forms. So we might have dy dx being the function of x, or dy dx being the function of y. We might have a combination such that dy dx is the function or functions of x and y. And to solve this type of differential equations, we use a method called separation of variables. So all those three are first order differential equations because the derivative is to the power 1. And we have second order differential equation when we are given the second derivative, but that will always be the function of x. And we'll look today at all those types. But we'll start with verifying solutions. And we'll also look at the alternate notation. So dy dx can be written as y dashed, and d2y dx squared, the second derivative y with 2 dashes, and that's what the calculator uses. So you could see the multiple choice SACA question trying to differentiate y equals x times e to the power x twice to find the first and the second derivative. Why do we need this? We need this when we are to verify that the given function, so in this case, the given function is y equals x times e to the power of x, is solution to this differential equation, d2y on dx squared minus 2 dy dx plus y equals 0. If you had a chance to download the webinar question the sheet with the questions, all those questions I'm doing will be there. So that's a good idea to actually have those questions in front of you. This type of question will be many than one. That's why I ask you to differentiate y equals x times e to the power x. So what does that mean that we verify? That means that we need to find the first derivative. We use the product rule, the product of two functions. Derivative of x is 1 times e to x, plus x times derivative of e to x is e to x. E to x is the common factor. Now we use the second, we differentiate again to find the second derivative of this expression, and if you did the poll, you would have found that the answer was e to x times x plus 2. So now if we look at our differential equation, we need to replace the second derivative with the given expression, minus twice the first derivative, and plus the function itself. To set it up properly, we would say the left-hand side of this equation equals, and we substitute the first, second derivative with the number. Now we take e to x as a common factor, and clearly we have x and x to x minus 2x is 0, 2 minus 2 is 0. So we can show that the expression actually is equal to 0, which is the right-hand side given in the equation. Therefore, it has been verified. This function indeed is a solution to the given differential equation. So that is type of a question you would have got in exam 1. But we look at another question now, which is the question where you could have the question like this in exam 2 as one of the multiple choice answers. So this time we have find the values of m for which this function now y equals e to mx is a solution of a differential equation. So what we'll do here now, we assume that we do have a calculator. So let's go to the calculator, and I can't escape, yes, finally. So you remember we earlier said that we can actually define our function, so y in x, and this time y in x here is the exponential function to the power m, and it's very important to put times x. You can't just type mx, it would think it is one variable mx. So our function here, which are to fulfill a differential equation, is e to the power mx. So what we could see in differential equation, there was the second derivative and the first derivative. So now using the template for the first derivative with respect to x, I can say y, and you see it comes bold because we have already defined it. So this is my first derivative. And similarly, I can find the second derivative with respect to x of my predefined function. So the calculator helps with this. Now we look back at our differential equation, which was twice the second derivative, so 2 times, and we go up and we get the second derivative, and then we had plus 7 times the first derivative. Here the expressions are not in brackets, so or just single terms, so we go plus 7 times the first derivative, and finally we have minus 4 times the function itself, so we just go minus y, and we need to put minus y next, it doesn't like it, very minus y in x, so that's better, and we get our equation. I deleted the wrong one, try again. Minus 4 in x, just delete the one here. So what the equation said, that this expression was meant to be equal to 0. So if I bring this down and I make it equal to 0, now I can do the following thing. I can go Control Menu. This is another shortcut if I don't want to go Menu Algebra Solve. Once I type the equation, I go Control Menu, and I have math actions I want to solve over real, but I want to solve this equation for m. And the calculator brings the syntax itself. So I get m equals -4 or m equals a half is the solution. This for those two m values, e to the power mx will be the solution to the differential equation. So let's go back to the PowerPoint. And it's done here, so it answers our question. So this could be exam 2 type question, and then the calculator helps you to pick up the correct option. So that's as far as verifying is concerned. Let's move to solving differential equations. And there are 2 types of solutions you can be asked for. We can get general solutions and we can get particular solutions. General solutions are if we are given the derivative and no initial conditions, as you know, our answer will be in terms, it will have a constant, same as indefinite integral. So let's try this question first on the calculator, and I will put a new problem so I don't have any interference there. Now, the trick here will be that I'm using CX2, and now those of you who have CX will have a slightly different view. I'll talk about it in a second. So where do we find solving differential equations? We go menu, calculus, and if we scroll down, D is differential equation solver. So if you have CX2, you will see this screen, which sort of tells you where to put things and tells you how we actually enter a differential equation. So I'll do this question using this screen, but the other questions I'll be just typing dissolve and using the syntax because most of you probably have CX CAS, not CX2. So our equation for this question was y dy dx. How we enter dy dx? We put y, and you need to press this button, and that's your dash. So that is dy dx. So to enter it into the solver, we need to write it this way. And the equation was equals. So now I need to use e, and that was to the power 3x. And then we had take away minus again e to the power negative 3x. Now you always need to tell the calculator which one is independent variable. It is x, and dependent variable is y. We're solving in general, so we don't have any conditions. So if I press enter, I get this funny looking thing. You probably came across that before, which is a cosine hyperbolic of 3x. How do we go around to see what it actually is? If you go to menu, algebra, expand, and we bring it down, I just want to expand this expression only inside. So it actually tells me that it is the same as e to the power 3x over 3 plus 1/3 e to the power minus 3x. So if you come across cos h or sin h, you need to expand because you won't see anything like that in your exam. So again, as you see, the calculator gives us plus C1, which is just plus a constant because we are solving in general. We were not given any initial conditions. So the answer here is 1/3 e to the power 3x plus 1/3 e to minus 3x and plus a constant. It depends how many you do. Next, the differential equation would have C2, C3, and so on. So this is a general solution. Now, another question, question 4 from the handout says dy dx is x squared plus 3 over x squared plus 4, given that y in 0 equals 1. So we are given a point. It is sometimes called initial condition or boundary condition. So let's see how we can enter this onto our calculator. So again, I will put a new problem and use the calculator, but this time, normally when you go not on CX2 to menu, calculus, differential equation solver, you will get that with the bracket, okay? Dissolve and the bracket. So I will do the rest using this way. So our equation again, that was the first derivative, so we say y dash is equal to, and we use a fraction, and the equation was x squared plus 3 over x squared plus 4. And what you need to do to enter the initial condition, you need to put a space now, and you say and, another space, and we enter the initial condition. Y in 0 is equal to 1. And now we go comma x, independent variable, comma y, our dependent variable, and enter. And the calculator gives us this time a particular solution. There is no constant in our solution because we have entered the initial condition. So most of you will be entering using dissolve this way. So you enter your differential equation. Then if you have an initial condition, you need to have space and space. Put the initial condition, comma x, comma y, for our dependent and independent dependent variable. So that's how we get a particular solution. There is no constant in it. Let's move to solving a second order differential equation, and again we'll solve two types. One where we are expected to get a general solution, and one when we'll be getting the particular solution. So we'll do it on a calculator and we'll discuss. So I insert another problem, the calculator, and again I type it, but you can go menu, calculus, and dissolve. So now I have the second order differential equation. So I go y, and I put one dash, and I go here again, and I put another dash. So I have that y two dashes, and the equation was plus y is equal to 3. And that was just the equation. Again, we go comma x and comma y. So notice what happens here. We got two constants, and those constants are clearly different. Because if you solve by hand, you need to find dy dx first, and then you get the first constant, and then you integrate again and get a different constant. It's really important to remember, if it's done by hand, you have to find the first constant first and then the second, not both constants somewhere at the end. So that is our solution here. In the exam, you could see here A and B and other questions. So that's okay. Now, this one is probably one of the hardest one to enter because that is the second order differential equation. And if we wish to get a particular solution, we need two boundary conditions. So we need the condition, what is dy dx equal for a particular value of x, and what is y equal for the particular value of x. So let's see how we enter this complicated question on our calculator. So I go again, doc, new document, new problem, calculator, and again I will type it because it is harder just entering it this way, not with the box. But as I said, if you have a box, you will know how to do it. We don't have a box with the older operating system. So our equation is y, the second derivative, so that's one dash, and I need to put another dash, plus y, so that was the first derivative, now we have plus y dash, and that is equal, to 1. So this is our differential equation. Now we put space and we say and we put space again, and we say, we put the first condition. We know that y dashed in 0 is equal to 3. And then we need another space and type and, another space, and now we go y in 0 is equal to 1. And then we again need to put comma x, comma y. So if we are not using the box on CX2, that's how this needs to be entered. And the calculator tells us the solution is y equals minus 2e to minus x plus 3, which indeed is a particular solution given those two conditions. So we need spaces unless you have CX2 where you can put option 1, option 2. Now this question I'll do by hand just to explain how the separation of variables works, and then we'll confirm with the calculator. So our differential equation y dx is x times y minus x, which means that we have dy dx as the function both of x and y. So how would we do that algebraically? If we say dy dx is x times y minus x, we'll take x as a common factor, and we have times y minus 1. Now what happens in the next step is something which we call separate variables. So I need to have one integral where I have the function of y dy. So I need to divide 1 by y minus 1 dy. And the second integral is x dx. This is called separation of variables. So that's how we solve by separation of variables by hand. Now everyone can integrate, refer to your BCA Specialist Maths formula booklet, log e modulus y minus 1, change to exponential. So we get y minus 1 is e to the power of x squared on 2 plus c. And now here's the trick if we do it by hand. We need to write e to the power x squared on 2 plus c as the product of e to the power x squared on 2 times e to the power c. Now e to the power c is a constant. So now we give it a different name. We say let this constant be called a. So we replace e to c with a. So the right hand side becomes a e to x squared on 2. And the last step is just adding 1, okay? If we try to do the same thing on the calculator, so let's say d solve, and our differential equation was y dashed is equal to, again remember, we have to have x times y. You do have to have this times there, otherwise it's not going to work. Minus x, and then we go comma x and comma y. And interestingly, the calculator actually displays it in the required form. Put C1 here, but that's your a. A e to x squared on 2 plus 1. So it's very similar to what was asked in the question. So again, this method is called separation of variables method. Of course, the integrals sometimes might become a bit more complicated, but if you're good at integration, you should be able to cope with those questions. Okay, let's try a few more questions from our handout. So we are up to question 7. So our differential equation this time is y dash, solve first, sorry, this one, and we have y dash is equal to, we have e to the power 2x multiplied times 1 plus y squared. So you would recognize that if you solve by hand, that would be separation of variables as well, comma x, comma y. But this time the calculator doesn't give us y as the function of x. When it solves, it says inverse 10 of y is equal to this expression. So what we can do, you can of course do it by hand and say 10y equals 10 of all that. If we ask the calculator to solve it, so now if I take all this and I wish to solve it for y, it does tell me that y is 10 e to 2x on 2 plus a constant, so it's okay to have a constant inside 10, but it also gives some conditions. Those conditions come from the definition of inverse 10. As you know, inverse 10 is between minus pi on 2 and pi on 2. So depending on the exam question, there might be, the conditions might be defined, but that's what the solution here is. Y equals 10 e to 2x on 2 plus a constant. And another example with initial conditions when we have separation of variables. So let's try this one. New problem, calculator. And again, we use the solve, and we are up to question 8. So we have y dashed is equal to, and we put a fraction, and again it is separation of variables 1 because dy dx is both the function of x and y, but we also have initial conditions here. So we say and we know y equals a half when x is minus 2, so I say y in negative 2 is equal to a half. And I will enter this as a fraction and talk about it, why it is important. And then we put comma x and comma y. So we get a particular solution and we get that as the exact form. If I change that and put 0.5 here, just good to be aware of those little tricks. The calculator sees, oh, that's decimal, so I actually don't mind having a decimal solution. There isn't much difference between those two in this particular example, but sometimes there might be a difference. You might just have only approximate values. So remember to enter everything as a fraction, because then we can actually see the difference, and we do want exact values, so keep fractions all the way through and exact values when we solve. So that is just to illustrate this particular difference. And that brings us to our last question, and that could be one of the multiple choice questions in the examination. To solve the differential equation dy dx, and it's pretty complicated, by separation of variables, we need to write it in the form. So one of those 5 options. Now, if we look at the numerator of this fraction, it's quite complicated, but remember it's multiple choice. So we actually have a calculator. So let's try to see how the calculator will help with simplifying the numerator. So if we go to menu algebra and we'll go to trigonometry, we have expand. We don't use algebra expand, we need to use trigonometry expand. And we had sine x plus y was in the numerator plus sine x minus y. So you don't need to use compound angle formula. If that is them too, you can ask the calculator to expand. We get 2 sine x cos y, and 1 is the function of x, 1 is the function of y. So of course, if we now go to our question again, we replace this with 2 sine x and cos y, and we separate variables. So we can now write that as e to x times e to y. So finally we'll see that our answer is B when we separate variables. The calculator helps here to expand. This bit you need to do yourself. Solving this on the calculator won't help you to find which option is correct. So this is all we have to present today on solving differential equations. There is students' worksheet, which is the follow-up from the webinar with some questions for you to try. Thank you very much for your attention.